Welcome back. Today, we're tackling a massive headache in the machine learning world, and that is taking those incredibly complex, super heavy models and actually deploying them onto the edge devices we all use every single day. Look, if you're a developer, a student, or a tech lead wanting to make your apps smarter without literally melting your users' processors, you are in exactly the right place for this explainer. So, here's the critical question. How do you run complex ML models in real time on a mobile phone? The industry data on this is actually wild. Think about this. Roughly 89% of enterprise execs see machine learning as absolutely crucial for their success. But here's the catch. Only about 22% of those brilliant data science models actually make it to production. Why? Bottlenecks. Deployment bottlenecks. Building a model in a pristine lab environment is one thing, but getting it to run at a solid 30 frames per second on a 4-year-old smartphone without draining the battery in 5 minutes? Yeah, that's a completely different beast. And the answer to that massive problem is Google's MediaPipe. It's an open-source, cross-platform framework, and it's specifically built for custom machine learning pipelines that handle live and streaming media. I actually love to think of MediaPipe using a restaurant analogy. When you build an ML app, you generally have two choices. You can either order off a high-quality, curated menu where everything's prepped for you, or you can walk right into the back of a commercial kitchen, grab the raw ingredients, and cook a totally custom dish from scratch. MediaPipe is super unique because it allows you to do both. And that's exactly what we're going to dive into today.
All right, so looking at our agenda, we've got 5 key areas to cover. First, the ML deployment bottleneck. Second, solutions, ready-to-use tasks. Third, the framework, custom low-level pipelines. Fourth, optimizing real-time performance. And finally, solutions versus framework.
Kicking things off with Section 1, the ML deployment bottleneck. To really understand MediaPipe, you kind of have to know its history. It was actually born internally at Google back in 2012, specifically to eliminate the massive friction of real-time multimedia processing on YouTube. Which brings us right to Section 2, solutions, ready-to-use tasks. Now, this is your menu option. It's completely designed for incredibly rapid development across Android, iOS, web, and Python. MediaPipe Solutions is basically made of 4 key components. First up, you've got tasks, which are your pre-built APIs for stuff like object detection or gesture recognition. Then you've got the models themselves. These are pre-trained and ready to run. But hey, if you need a little customization, let's say you want to recognize a specific custom hand gesture for your app, you can use Model Maker to apply transfer learning using your own data. And finally, MediaPipe Studio lets you evaluate your model right there in your web browser. Using these tools together, you can run state-of-the-art ML inferences with literally just 5 lines of code. No joke. Just look at what a high-level vision task looks like right out of the box. With those few lines of code, the Object Detection API instantly identifies a bowl, an apple, an orange, and a water bottle, complete with the bounding boxes and labels. Think about it. You didn't have to train a neural network from scratch. You didn't have to write complex image pre-processing logic to convert pixel arrays. The Solutions API handled all that heavy lifting for you. It's fast, it's efficient, and most importantly, it just works. Moving into Section 3, framework, custom low-level pipelines. All right, we're zooming in from the telescope to the microscope here. We are stepping right into that commercial kitchen. To really grasp the framework, you've got to understand its core anatomy. And it all starts with packets. Think of a packet like an envelope. Inside this envelope is your data, maybe a video frame or an audio sample, and stamped right on the outside of the envelope is a numeric timestamp. This is absolutely crucial because media isn't static, right? Time series data has to be perfectly synchronized. These time-stamped packets flow sequentially through streams, ensuring that your audio data perfectly matches up with your video data during processing. So where exactly did these packets flow? Well, they flow into calculators, which are also known as nodes. If packets are the envelopes, calculators are the processing clerks. This is where the actual heavy lifting happens, whether that's image cropping, tensor conversion, or running the neural network inference itself. And what's really brilliant about this setup is that these calculators are completely modular. They can run concurrently using custom thread pool executors, which means you're processing different parts of your data in parallel across multiple CPU cores. When all those pieces come together, they form a directed acyclic graph, or a DAG. You can see how the camera input at the top feeds data down through these different calculator nodes, like frame selection, object detection, and detection tracking. The data is flowing right along the lines, representing the streams, and all of it is kept perfectly in sync by those packet timestamps we talked about. By just writing a simple configuration file, usually a .pbtxt file,
A developer can build this highly customized, multi-threaded perception pipeline without having to manually write all the complex multi-threading and synchronization code from scratch. It's a huge time saver.
That leads us nicely into Section 4, optimizing real-time performance.
So you might be wondering, how does this complex graph architecture actually achieve near real-time latency on a tiny little edge device? Well, the secret sauce here is hardware acceleration delegates. MediaPipe intelligently offloads workloads directly to the best available hardware on the target device. So it uses XNN-Pack for highly optimized CPU processing, but it can also instantly tap into mobile and desktop GPUs using OpenGL, Metal, or Vulkan. And get this, if your device has a dedicated neural processing unit, or NPU, it uses LightRT to route the neural network execution directly there. The result? You get maximum hardware efficiency without having to reinvent the wheel for every single device platform out there.
Now, to manage flow control, the framework uses a very specific advanced tool called the flow limiter calculator. Picture this in the real world. A camera might spit out video frames at 60 frames per second, but your heavy ML model, it might only be able to process 15 frames per second. If you just naively queue up all those incoming frames, your memory's gonna explode and your app will crash, for sure. The flow limiter calculator prevents that by actively monitoring input congestion. It dynamically drops older packets, literally skipping video frames, to ensure the pipeline is always processing the absolute freshest, most recent data. It's a critical tuning mechanism to avoid system deadlocks.
And finally, Section 5, Solutions versus Framework.
Let's break this down. If you're a student hacking together a weekend project, or maybe a developer just trying to quickly add standard face detection to an app, the solutions route is a total no-brainer. It gives you low complexity and super fast development speed. It's absolutely best for mobile or web integration. But on the flip side, if you're an enterprise tech lead building some proprietary perception system that requires weird custom hardware sensors and heavily modified models, well, you really need to use the framework. It's going to give you that full control over the pipeline logic you need, even if it means a slower, more custom development cycle.
So, here is the ultimate trade-off for you as a developer. You're balancing the need for rapid development speed against the requirement for ultimate flexibility. Are you just prototyping something for mobile or web? Go with Mana Solutions. Are you building an enterprise-grade custom hardware pipeline? Time to roll up your sleeves and dive into the C++ framework. Honestly, neither approach is objectively better than the other. They're just different tools for entirely different stages of the engineering lifecycle.
And that brings us to the end of our explainer on Google MediaPipe. We've journeyed from those high-level APIs that give you instant object detection in just 5 lines of code all the way down to the synchronized, multi-threaded packet streams flowing through custom DAG architectures. The deployment bottleneck? It's really no longer an excuse. The tools are built, the models are trained. The only question left is, what are you going to build next? Thanks for tuning in, and keep learning.